Hello, this is Mrs. Huntley. This is video 5 of the Pythagorean Theorem supplemental packet. We're going to be talking about finding distance on a coordinate plane. I'd like you to turn in your packet, please, to page 13 or about page 13. And I want you to add the essential question at the top of the page. First of all, make sure the top of your page looks like mine and it says distance on a coordinate plane. And then add the EQ at the top. How can I use Pythagorean theorem to find the length of a diagonal line drawn in a coordinate plane? If you didn't have enough time to copy that down, go ahead and pause the video because I'm going to keep talking about something else that I want you to pay attention to. So at the top of this page, we've got graph A and graph B. And graph A and B are both showing you only the positive quadrant of a coordinate plane. I know you've seen this before, but a coordinate plane, you may have just the positive quadrant, or it may have all 4 quadrants. And what a coordinate plane is it's 2 intersecting number lines. You have a vertical number line and you have a horizontal number line. And where they meet in the center is where both number lines are equal to 0. So this point right here in the center is called the origin, and that's where my horizontal number line, which I call x, is equal to 0, and my vertical number line, which I'll call y, is also equal to 0. So as we go up on our number line, this is the coordinate would be 0, 1. This would be 0, 2, 0, 3, because I have an x coordinate and a y coordinate in my coordinate plane. So that's just a really quick review. And sometimes these are called a Cartesian graph. And if you make a C, this is how the graph is numbered. This would be quadrant 1, quadrant 2, quadrant 3, and of course quadrant 4. So that again is just a quick review of what a coordinate plane looks like. We're not going to be dealing with all 4 quadrants right now, but I wanted to spark your memory of what that looks like. So graph A and graph B, we're just looking at the positive. This would be quadrant 1 in the coordinate grid. And in graph A, it's pretty easy to find out how long that line is that's drawn in graph A because I just can count the units. It starts at 1, 3 and it goes to 4, 3, and I can just count the units as I'm going to the right. So I'm starting here. Here's 1 unit, 2 units, 3 units. So I know that that is 3 units long. When I look at graph B, it's going on a diagonal. So I can't count the units anymore. This is a partial unit, a teeny tiny bit of another partial unit, another quarter of a unit, another quarter of a unit. I can't count it. It doesn't make sense. I won't be accurate. So what I need to do is something different. So let's take a look at the notes here. It says sometimes looking at the distance between points on a coordinate plane is as simple as looking and counting the number of units, like graph A. Other times we might need to find a diagonal distance, like graph B. So what we're going to do is to find a diagonal distance in a coordinate plane. We can create our own right triangle and use the Pythagorean theorem to calculate the distance. The diagonal distance would then represent the hypotenuse, or the C side. So let me explain to you what we're talking about here. On graph B, what I can do, and how I like to look at this, remember I told you I personify things and I look at things sometimes a little bit differently than your average bear. I think of this as a map of streets. And if these were blocks on a street, and this is the distance that a bird is flying, because the bird can fly over the houses, I need to find out if I'm chasing that bird using my car or my bike or whatever I might do. I can't fly through houses, so I've got to go on the roads. So I'm going to go down the road this direction, and then I'm going to turn and go down the road this direction so that I can meet up with wherever that bird is flying. If you notice, I turn right, and I have a right angle here. So that is now my hypotenuse, and I've got 3 units going down, and then I turn the corner, and I've got 4 units going over. So I can use my a squared plus b squared equals c squared and figure out the length of that diagonal there. So I'm going to do 3 squared plus 4 squared equals c squared. 3 squared, of course, is 9. Good. 4 squared is 16 equals c squared. 9 plus 16, 25. Take the square root of both sides. and C is going to equal 5. So this diagonal distance here is going to be 5 units. And that is how I will use the Pythagorean theorem to help me figure out the length of a diagonal in a coordinate plane. Let's move on to some examples here. Okay, so they're giving us some points, A and B on each graph. I'm going to use a straight edge because I want to be as exact as I can be, and I'm connecting those points using a straight edge. I'm going to make that straight edge a little bit thinner. Let me see if I can do this. There we go. So it's not quite so fat. Let me get rid of that one. Okay, so to find the distance between A and B, I need to create my triangle. So I'm going to go from A up however many blocks I need to travel before I turn right and then get to B. So now I can count some units. I'm going up 1, 2, 3, 4, 5 units before I turn, and then I'm going 1, 2, 3, 4 units. So I can use my Pythagorean theorem now. I'm looking for the C side. So go ahead and set this up. And 5 squared, of course, is 25. 4 squared is 16. 16 plus 25 would be 41. Square root, square root. I've got 6.40312. Okay, and it says round to the nearest tenth. So I'm going to say about 6.4. Okay, see if you can pause the video and do number 2. You know what? After each part of doing number 2, unpause the video and check your progress. So first things first, draw your triangle. Going from A to B, you can go down and over. That's fine. If you had gone, let's say you did this. You went over this way and then down. That's fine. Doesn't matter. So this is 2 units. This is 1, 2, 3, 4, 5, 6, 7 units. You know what? I have to recount. Hang on a second. There's 1, 2, 3, 4, 5, 6, 7. Okay. That is correct. When I did my key, I counted differently, so I just glanced at what it should be, and I thought I was wrong. So 2 squared is 4. 7 squared is 49. 49 plus 4 is 53. Taking the square root would be 7.28. So I'm going to say C is approximately 7.3. And I should have units written in here. I'm sorry that I didn't do that on this one. We should always say what our units are in case we're dealing with different kinds of units like miles or inches or something like that. Okay, so number 3, again, we're going to draw our line. Make your triangle. Once you make your triangle, come back and check to see if I made the triangle the same way. Pause the video now and make your triangle. Okay, that's how I'm going to make my triangle. Again, if you made your triangle going this way, that's fine. You're going to get the same number of units. Hopefully you're using a straight edge and you made straighter lines than I just made. So I'm going to get rid of that one. But either way is fine. You're going to get the same number of units. Going up 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And this is my right angle. I'm looking for the C side. 8 squared is 64. 64 plus 64 is 128. Square root both sides. It's going to be 11.31. So C is about 11.3 units. There's the quadrant that we did. Okay. So the next part says, use the graph and the Pythagorean theorem to find the distance between points. So they want us to graph a point, and you'll notice that we have a full Cartesian graph here, okay? So the first one, they always give us our coordinates as x comma y. So x is always our right left, y is always our up down. So if I'm going to go x is -6, I'm going to come out here to -6. That's where x is -6, and then I'm going to go up to 1. That's where my first point is. I'm going to label that point A. Next is going to be -4, 5. Come over again, always start in the center, come over to -4, then go up to 5. And that's where our point B is going to be. So that's, I'm going to color code. So this is A and B in green. Okay, so I'm going to draw my line in green. Oops. And I've got to figure out that distance using the Pythagorean theorem. Okay, so first steps first, I'm going to draw my triangle. I'm going up 1, 2, 3, 4 units, and then over 1, 2. Setting that one up for you, and I'm going to let you continue working that out to find that diagonal distance. I'm going to go ahead and graph the next one. And again, I said I'm going to color code, so this one I'm going to do in green, or in blue, I'm sorry. So -7, -7. So I'm going to start in the center, go to -7, and then down to -7. Remember, my right left is always first, up down is second. So 4, -3, I'm going to come over +4 right here, and then down to -3 right there. I'm going to get rid of these stray lines or stray dots so you don't think that there's something. I have to make dots so you know where I'm at since you can't see me. Let's do a line. Whoops, come on now. Let's do blue. There's my blue line that I'm trying to figure out for the second one. So again, my next step is going to be to make my triangle. Go ahead and pause the video and make your triangle here. So 4 squared plus okay. Hopefully yours looks something like mine. And for the last one, I'll go with red. So, whoopsie. Let's try to undo that. Zero, 2. So I go right or left 0, then up to 2. Call that A. 7, 7. Come to the right 7, then up 7. Call that B. Going to draw my line. In red. And again, draw your triangle. That's going to be your next step. Drawing your line, going up 1, 2, 3, 4, 5. So 5 squared. 1, 2, 3, 4, 5, 6, 7. Okay. So go ahead and for 4, 5, and 6, you're figuring out the length of the diagonal. I helped you set them up. I used some color coding. Hopefully this is making sense to you. Of course, bring any questions that you might have to class tomorrow. Thank you. Have a good night.